So the last one we did, and I'm just going to put the result up. Okay? The last limit we did was the limit of the function 2 times e to the 3x minus e to the 2x over 4 times e to the 3x plus 7 times e to the 2x as x increases without bound. Okay? And we showed that that is equal to 1/2. So write in behavior, write the graph of this function. Okay? There's a horizontal asymptote, y equals 1/2. Now let's look at the left-end behavior for this function. Okay? The limit is x decreases without bound. Okay? So this is left in behavior we're talking about, right? In the graph of this function. Up here, okay, we divided the numerator and denominator by e to the 3x. And then took the limit as x increases without bound. We're going to take a little different approach with this limit. Okay. In the numerator and the denominator, right, there's 2 terms in the numerator, 2 terms in the denominator. The lowest power of e is e to the 2x. So we can actually factor out an e to the 2x in the numerator and in the denominator. So let's do that. And so when I factor out e to the 2x in the numerator, I have e to the 2x times 2 times e to the x minus 1. And you can verify that, because you know if you distribute the e to the 2x inside the parentheses, you have 2 times e to the 2x times e to the x. And when you multiply e to the 2x times e to the x, you add the exponents, and you get e to the 3x. And then minus 1 times e to the 2x is minus e to the 2x. Okay. And now when we factor out an e to the 2x in the denominator, we have in parentheses 4 times e to the x plus 7. Well, you know from the natural exponential function, right? Here's the graph of the natural exponential function. You know the graph of the natural exponential function looks like this. Crosses the y-axis at the point 0, 1. The natural exponential function is positive for all values of x, right? It never equals 0. So e to the 2x never equals 0. So e to the 2x divided by e to the 2x is 1, right? They cancel. And we are left with the limit as x decreases without bound of the quotient 2 times e to the x minus 1 over 4 times e to the x plus 7. Now you can either show this with a table of values, or you can look at the graph. As x decreases without bound, what's the graph telling us here? As x decreases without bound, e to the x is getting closer to what number? 0, right? And you can demonstrate that with the table of values if you want to. Okay. So, as x decreases without bound, the numerator approaches 2 times 0 minus 1, and the denominator approaches 4 times 0 plus 7, right? Now, you don't have to do this on exam. I'm just going to do it for this class, right? But the limit from the rules of limits, properties of limits, this limit can be brought in the numerator and denominator. So we have 2 times the limit as x decreases without bound of e to the x, and we get minus 1 over 4 times the limit as x decreases without bound of e to the x, and then plus 7. You wouldn't have to put this on an exam, right? But I'm just showing you where the 0 is coming from. And so this limit of this function as x decreases without bound is equal to 2 times 0 minus 1 over 4 times 0 plus 7. And when you simplify that, you get minus 1/7. So as x decreases without bounds, okay, the value of this function approaches the number minus 1/7. And so does the graph of this function have a horizontal asymptote on the left end?
Yes.
What's the equation of the horizontal asymptote? Y equals minus 1/7, right? Yes, ma'am.
So on the right end behavior, could you also have done the factor out the e2x
You could.
and gotten the same 1/2?
Yeah.
Okay.
Okay. But you would have had to do some additional algebra after that.
Okay.
Okay. Because you would have ended up with this, right?
Okay.
And then you would have had to divide top and bottom by e to the x.
Okay.
Right? Because as x increases without bound, 2 e to the x minus 1 increases without bound, and 4 times e to the x plus 7 increases without bound. So you basically got infinity over infinity. So you have to divide the top and bottom by e to the x, right? To show that this goes to 2/4, which is 1/2.
So you should only really do the factoring for left end behavior?
In this case, because it's a natural exponential function.
Okay.
A lot of times when I do limits in class, I did them 2 or 3 different ways before, and I thought, oh, this is taking too long. I'm going to try it this other way, okay? And what I often put on the board is the shortest method, not the longest. Okay? So that, so I could have done that she's talking about. In evaluating this limit, instead of dividing top and bottom by e to the 3x, I could have factored out an e to the 2x like I did here, but then I still would have had some additional work to do when I got to this part right here. Okay. And so I think I tried to do that the first time, and I thought, man, this is taking too long. There's got to be a faster way. And so I divided top and bottom by e to the 3x.
But even if you were to go a longer route, you would still make it.
Well, yeah, you would still end up with 1/2. Right? And it would not be wrong to do that. You're just taking a longer route. Okay? It's kind of like in pre-calculus when you got a quadratic equation, variable x equal to 0, and you got to solve for x. You can factor, or you can use quadratic formula, which is faster, okay? And that's kind of what, right, situation I was here, which is faster. Yes, sir.
So instead of using the graph and using that e to the x equals 0, could you instead just use direct substitution for negative infinity into the x?
Do what?
Instead of evaluating using the graph and that e to the x equals 0 and just putting that in, could you instead use direct substitution and put the negative infinity in the exponent?
Well, I mean, and then what are you saying? That e to the minus infinity is equal to 0?
Well, yeah, it's just a different way of approaching it. Like,
Yeah.
that works.
So, I think it's better. What, so you would have put minus infinity in for x over here?
Well, no, once you reach the end, like instead of just
Right here?
2 times, yeah, instead of making e to the x equals 0 by, using the graph and doing what y equals, could you instead just put negative infinity in the exponent?
Well, you don't even have to do that. You can go from here to here.
Okay.
Because it's implied, because we know that as x decreases without bound, e to the x goes to 0.
Okay.
Yeah. Okay. All right. Any other questions? All right. Una más. We have the limit as x increases without bound of x minus the square root of x squared minus 2x. Now, using the rules of limits, right, you know that the limit as x increases without bound, the limit of x as x increases without bound, increases without bound, right? And the limit as x increases without bound of square root of x squared minus 2x can also be shown to increase without bound, okay? Because x squared dominates minus 2x. Okay? When you bring the limit sign under the radical, right, this is a polynomial of degree 2, and this is the leading, x squared is the leading term, and so the limit as x increases without bound of x squared is increasing without bound. So looking at this up here, it might look like the limit as x increases without bound of x minus the square root is equal to infinity minus infinity, which is equal to 0. That's what you might conclude, and that is wrong. Because this limit actually equals a real number, not 0. Okay? So infinity minus infinity, you cannot conclude is equal to 0. Okay? So what we have to do is rationalize the numerator. The numerator is x minus the square root of x squared minus 2x, and the denominator is 1. Anything divided by 1 is itself, right? And so, to rationalize the numerator, you're going to multiply top and bottom by the conjugate of the numerator, right? Change the minus to a plus. So we have x plus square root of x squared minus 2x over 1 times x plus the square root of x squared minus 2x. So when we multiply top bottom by the conjugate of the numerator, right, we have product of the form a minus b times a plus b. And you know a minus b times a plus b equals a difference of squares. The difference of squares, a squared minus b squared. That's why we do the conjugate. Okay? So a in this case is equal to x and b is equal to the square root. So when we FOIL the numerator, we get a squared minus b squared, which in this case is x times x, or x squared, and then we have minus the square root squared. All over x plus the square root of x squared minus 2x. Does everybody follow me? When you multiply this difference by its conjugate, when you FOIL, you just end up with the first term minus last term, right? So this is equal to the limit as x increases without bound of x squared minus, now squaring in the square root, and we end up with x squared minus 2x in parentheses. Okay? We're not just subtracting x squared, we're subtracting x squared minus 2x. Okay? It's got to be in parentheses. Over x plus the square root of x squared minus 2x. And now when you distribute the minus sign inside the parentheses, we end up with x squared minus x squared, which is 0, and just 2x in the numerator. Well, the numerator is increasing without bound, and the denominator is increasing without bound. But we can divide top and bottom by x, right? When we divide top and bottom by x, two x over x plus the square root of x squared plus 2x over x.
It should be minus 2x.
Oh, thank you. Thank you, thank you, thank you. Minus. So 2x over x is 2. And then x over x is 1. And then when you divide x squared minus square x by x, you actually divide it by the square root of x squared, right? You change x to the square root of x squared. And then when you do that division, x squared minus 2x over x squared, you end up with 1 minus 2 over x. We did this kind of stuff on Friday. Okay? So when I divide the denominator by x, when I divide the square root by x, I'm actually dividing square root by square root of x squared. And then under the radical, that simplifies to 1 minus 2 over x. Well, as x increases without bound, 2 over x goes to what? 0. So this is equal to 2 over 1 plus the square root of 1 minus 0. Right? The larger the value of x, the smaller the value of 2 over x. And that arithmetic is equal to 2 over 2, which is equal to plus 1, that's 0. So your impulse might be this limit, infinity minus infinity is equal to 0. But in reality, as x increases up bound, the limit is equal to 1. And so the graph of this function has a horizontal asymptote, y equals 1. Any questions on that? So that was like the last 2 problems you needed to complete the web-assigned homework. Okay. Any questions? Okay. All right. So we'll use the remainder of the period to take your quiz.